I want to welcome you back to this channel where we have our lectures about mathematics and physical science. And at this very moment, we are handling how we deal with motion on an inclined plane. However, we have gone through very many cases, and now we are actually on case 3, where the force is going to be applied on the body, but that force will be at an angle to the line of greatest slope. Now we said if the plane is smooth and we have a body resting here, there is definitely a weight acting on the body, which is mg. And I also emphasize that if at all we go ahead and put the poles, we have the axis, we have the vertical and the horizontal. So we know that weight acts at an angle to the vertical, and that angle is equal to the angle of inclination theta. And then alongside here, we have our reaction. The reaction is along that line. And now this is R. Today we looked at horizontal force up the line of greatest slope. Now I want to look at the case where the force is at an angle to the line of greatest slope. And so if I have a force at an angle to the line of greatest slope, that force can act here. Let me call that force F, and let me say the angle is alpha. Okay, so this is a force at an angle to the line of greatest slope, or at an angle to the line of greatest slope. It can act here, it can also act in this direction, but I'm looking at a case where it is acting at an angle and up the line of greatest slope. Okay, so we know, as for starters, you can always come to this and reproduce it. Reproducing it, you start from the fact that we have both the axes, vertical and horizontal. Now, alongside the vertical, that's where we have our reaction, R. Then over here, we have our force. I think you can see in this quadrant, we have a force, F, which is at an angle alpha to the horizontal. And then down here, we have our weight, mg, acting at an angle theta to the vertical. Ladies and gentlemen, these are the forces acting on the body. And so we said when you have this, it's always very easy. You come and obtain resultant force. Okay, so your resultant force, which I normally call Fr, will be, when you start with the reaction, this will be 0R. Then you come to this. Now that's positive direction, so we have F. We have F what? F cos alpha. Then we have F sine alpha, positive, because it will move up. Yeah, someone doesn't know how it is a positive. Of course, if you get components here, the horizontal component, you can see it is moving in positive, and the vertical component is moving upwards, so it's also positive. So we now come to this one, mg. That's minus mg sine theta, and here is minus mg cos of theta, and this is equated to 0, 0, if the system is in equilibrium. Okay, but it's possible that the system wasn't in equilibrium. Now, by the way, we can apply a force on this body, but the body still moves down. That means the force will be small. And so for today, let me assume that we apply a force there, but the body still accelerates downwards with an acceleration A. This one is similar to what normally happens when a weak person is having a wheelbarrow in their hands. So if this was a wheelbarrow, and whoever is holding the wheelbarrow is a weak person, that means there's a component of weight here, mg sine theta. And so if this wheelbarrow is really loaded, that means it has a bigger force, and the force because the force in your hands is along here, okay? But you find that this force is not big enough to sustain this body, and so the wheelbarrow ends up accelerating downwards. That's what I'm saying, that here we can apply a force upwards, but the body still accelerates downwards. And so if it accelerates downwards, remember I told you that means that even in your produced diagram, you'll have to come and indicate the direction of acceleration. You say it's here, it's down there. So that now when you're resolving, in this case where we have acceleration, you come and say my resultant force F shall be, the reaction is always 0R. That one is so simple. And then now the force, you can see that if I take the components of the force, you see this is Fy vertical, this is Fx. I think you see the horizontal is in opposite direction with acceleration. That's why it will take a negative. So this will be minus F cos alpha, whereas vertically it will be F sine alpha. And then you can also see that if I come to the weight, when I take the components of the weight, this is downward, and this is, so you see horizontal is in the same direction as acceleration, so it will be positive. That's why this will be mg sine theta, whereas this one still will be minus mg cos theta. And this is going to be equated to, because of acceleration, equated to ma 0. And so this happens when the body is accelerating. Okay. Yeah, so now we want to look at some examples. Let's look at example 1. We're taking our first example. And like you can see, we have it a mass of 5 kilograms. We have 5 kg as the mass inclined at 30 degrees to the horizontal. The force is acting up and at 60 degrees along the line of greatest slope. So that's the important information. And as you sketch, you know that we have here 30 degrees. So I have my force, my body. There are two forces. First of all, I have the weight, mg. And then do not forget to remember that we have our axis there. So that your reaction acts here. That is your reaction. And then we have a force acting up and at 60 degrees. So you have 60 degrees to the line of greatest slope. So that's what they mean. The force is F. So you can, of course, produce, like we have been doing, say that you have a vertical and a horizontal. Then you have your forces. You have the reaction, the force itself. This is R, F, 60 degrees. And down here you have mg at 30 degrees. Okay, so in part A, the body is in equilibrium. So our resultant force F will be equal to, start with reaction, that will be 0R. Go to the force. Now the force horizontally it will be F cos 60, vertically it will be F sine of 60. Then you add the weight, which is minus 5g sine 30, and then minus 5g cos of 30. This is equal to 0, 0, because this thing is in equilibrium. So if we go horizontal, you can have F cos 60 minus 5g sine 30 is equal to 0, such that you can have our F as equal to what? So you can use your calculator, then you see this will be Fp sine 30 out of cos 60. I don't know how many of you know that cos 60 is actually equal to sine 30. So these ones can cancel. So F will be 5g newtons. Then in our part B, the body is accelerating. In the part B, they say the required force to make the body accelerate down by 2 meters per second. So you can indicate the acceleration 2 meters per second squared. Also here 2 meters per second squared. Such that when you're obtaining your resultant force, you'll have 0r plus. Now, are you seeing that this will become a negative? Because it is not in the direction of the acceleration. Yes, that's how important it is to look at the direction of acceleration. And then these ones now, this one now become a positive. That is 5g sine 30. This is negative 5g cos 30. This is equal to ma. So that is 5 into 2. And here it's a 0. So that if I go horizontal, what shall we have? We have minus f cos 60 plus 5g sine 30 is equal to 10. Now, when you solve this, you'll see that F will be equal to 29 newtons. Yeah, prove me wrong or prove. Convince yourself that it's 29. So this is what you're expected to do. You get a bonus there. Can give you a method here and accuracy, a method and accuracy, so to get your 5 marks. Otherwise, I thank you for watching this video up to the end. And this marks the end of our series of the inclined plane. In case of any questions, please put them in the comment section. Don't forget to like the video and do not forget to subscribe to our channel. Also share the video with others so that we all share the knowledge that we have obtained from this video. I am going to put a link that will lead you to some discussion questions or trial questions. In case of any challenge in one of them, please do not fail to reach out to me. I'll be very glad to help you with the challenge. I want to wish you a nice and blessed day. God bless you.